Okay, so here I am using the Meta Hyperon library that is basically the integration with Python, and I'm using it from the Clojure libpythong library. So let's see how that will turn out. So here they say Python is great because it already has an ecosystem and we can embed, and we can go both ways as well, which is also cool. Embedding Python objects allows us to have subsymbolic neuronal nets, for example, implemented in Python or something. The other way around, I can use Python as glue language, I don't know, for AI agents. I mean, whatever. It's good to have the other way around, writing Python code that uses Meta. I mean, I also want to parse files or something sometimes and then call Meta. I think that would just make it. This is just what I need right now in order to get anything done with the language, so it's good that they have that. Okay, so I have a Clojure REPL running that runs with a Python environment, hopefully. That runs with libpythonclj. Legal argument. I don't know why. Maybe because maybe there's something you need to load. Maybe there's some library I needed to load that sets up some state or something, that sets up some variable while it loads or something. I'm not entirely sure. I think this was because I used sync depths after I added the depths. Yeah, I don't know. Okay, works now. Okay, and then so basically what works is that, yeah, I have here a Python script. So this is the first thing here. Pip install Hyperon, I did this. And then I made a hello meta Python script, this one. And when I say bash, well, when I run this with Python, it works. We run a Hyperon interpreter. That's basically a Rust library that has bindings for Python. This is provided by this Hyperon package, and we can do the same thing. So I'm just gonna write the libpythonclj code from Hyperon imports. How does require Python work again? I can IRS. I think this is the equivalent. Hyperon.meta as meta. Okay. I guess this is the super high level API. Okay, so now make a meta. I guess this is basically a meta evaluator now or something. This works, right? No. Unable to resolve. Like this? Does this work? No. Okay. So I need to. So I should have said refer. Whatever. I just import Hyperon as hype. Okay, this makes more sense to me anyway. Having namespaces. Okay, this works, I think, like that. Yeah. Okay, this makes a Hyperon runner meta object. Okay, put this into a variable. And then meta, this is a Python object now, so I say run and then with some string. Okay. I'm gonna type a string here for the moment. Foo boo. So this is meta code now. Foo is boo, then evaluate. Foo, then evaluate match. Ampersand self, the familiar stuff. Anything F is boo, and then f. Okay, so this should be a result set of foo. Okay, run this. Oh, I get boo and foo. Yeah. Works. That works, but it's of course it's of course that would of course be a little bit inconvenient to program, but yes, we can already use I mean we can use meta from Clojure now. I mean if I want to do some strange thing, like say I have some persons like Bob, Alice, Charlie, and now I just call format. For example, I just build some meta code and I say person, for example, right? Now I have some meta code and then maybe I say yeah, I just say one sec, I just say run, and that's already useful. Py meta run. Maybe like this. Yeah. So now basically I should be able to ask the meta for all persons or something like that. So I say run. Then of course I need some string again, but I could also write a meta code file here quickly. Say query persons or something. Dot meta. Now I have my meta mode here, so I get my autocomplete a little bit for some stuff. Can also say command log mode again. So match $self all the persons. Person X and then return the X. Here I need a variable. Okay, cool. So I'm writing meta code. And now I use Clojure to build a string. In this case, I just slurp this file here as the query. And I evaluate this. Nothing. Not correct. Not what I was. I'm not evaluating this. Okay, and there you go. Boom! And now I have this Clojure data here. Alright. It's like in some ways it's like super trivial, but in other ways it's actually quite remarkable. Okay, let's keep going. The result of run is a list of results of all evaluated expressions following the exclamation mark. Each of this result is also a list, each containing one element. Okay, so for this thing, now I get it. So I get it even more often now, yeah. So it's a list of results. Okay, and each of those are lists. Yeah, that's true. The results are not printed to the console by meta run. They are just returned. Thus, we print them in Python. So yeah. That's what they mean. In the script, they need to do something with the result, else nothing will happen. Let us know that meta instance preserve their program space after run has finished. Thus run can be executed multiple times. I already saw that. Yeah. Yeah, sure, you can do something like this. Okay. Parsing meta code. The runner has methods for parsing a program code instead of executing it. Parsing produces meta atoms wrapped into Python objects, so they can be manipulated from Python. Creating a simple expression, atom, also tuple A, B looks like this. Okay, I can also do that. So meta, I take the meta runner and call a Python function called parse single. I wonder, can I, wait, I can, there's a way, wait, there's a way, list, objects, wait, can't I, no, this doesn't work, yeah, it works for modules it works, I could jump to the definition of this, no, I can't, sometimes, here I can, okay. Okay, this is already useful enough for me. Yeah, I don't like writing function names without having an autocomplete. It's basically, I want this for not having typos, basically. Yeah, okay, so here is a B, for example. Okay, this prints as... it just prints, yeah, because this is, I think this is a Python tuple prints. This is quite nice. Oh, this is a list. What is actually the type of this? Py get type or something? Wait. Type. Attribute type, ne? That was what I was looking for just now. Naja. There's something like Python type. I know this exists. But maybe this is in a Python type, yeah, Python type. Okay, this thing is called expression atom. Okay. Prints like a tuple. Man, this is so amazing. The integration between Python and Clojure is so good. Shout out to Chris Nuremberger. Like, this is truly amazing work. Yeah, because I can, for example, here I get a tuple. Now I say in Clojure, I say make a vector. This doesn't work. Okay. Expression atom has no attribute iter. Did you mean string? No, didn't mean string. Okay, this didn't work. Okay, cool. Iter didn't work. Can I call first? No. Nah. This is their fault. They didn't implement an iter for tuple. This would have made sense though. Naja, okay. Parse single, okay. That also returns the first one. So for this you need to call a different function called parse all. CD, okay, this probably returns a list of things now. Parse single, yeah. Parse single returns only the first. Parse all returns a list. Parse all method can be used to parse the whole program code given in the string and get the list of atoms. Yes, I just did that. Accessing the program space. Let us recall that atom space, or just space, is a key component of meta. It is essentially a knowledge representation database. Which can be thought of as a meta graph. And the associated meta functions are used for storing and manipulating information. One can get a reference to the current program space which in turn may be accessed directly, wrapped in some way, or passed to the meta interpreter. Having the reference, one can add new atoms into it using the add atom method. Okay, we can do this in Python as well. So I say meta pi. So that is space. Okay, this returns a space. Okay, cool. And then add atom. Atom. Okay, I don't know what atom is. I think I need to make an atom or something. Now let us call run method. What atom? What is atom? Ach, I needed to pass one? No. Ah, yeah, wait, here we passed one. Well, yeah, I can pass an atom, yeah. I can make an atom. For example, this. AB. Add atom. I guess it should work. Yeah. And now we can query again. Here they do exactly this. Okay. And now you say pi meta run. You type hyperon code, meta code. I mean, in terms of string. X. Yeah, of course. Yeah, this should actually give me B. It should give me a list of B. No. Yeah. It works. It works. The program pass to run contains only one expression, this match expression. It calls the match function for the pattern. Yeah, I know. The result will be a list of lists with B, which means that add atom has added a B. The expression extracted from the string by parsing the code past this, and then add atom is effectively the same as this. That's true, because this is the space. This is what this is doing. It's just putting this atom into the current space. Yeah, please note that atom parse all is not precisely equivalent to evaluate this 0. Why should this be? Although the results can be identical, the expression passed to run will be evaluated and can get reduced. Here I say evaluate AB. That should give me AB, okay. And here I say atom parse all. So, yeah, I mean, if you have side effects, for example, this is something else. This is different. This is different if you have side effects for sure. Here you say parse. I mean, parse, that returns, that's the parser, right? That is just, but here I parse and then evaluate. Of course, this is different. Will be evaluated and can get reduced. Yeah, this as well. Yeah. So here I have, here I pass an atom, and here it might be reduced as well. Yeah, if you have +1, 2, yeah. Yeah, that was kind of obvious. Evaluate AB. Okay, that returns something like that. I can say N0, I can say that, yeah. Now you say meta run +1, 2. That actually evaluates something. But that would be different if I say meta pass all. Pass all, yeah. That would be without the exclamation mark. The expression +1, 2. I guess, or whatever the output of a parser is. I guess that would be an expression, or you can ask the pi type expression atom. Okay. Yeah, the other one I already know. Okay. parse single or parse all are more useful when we want to add atoms to the program space, but when we want to get these atoms without reduction and to process them further, they are not so useful if we want to add. No, they are more useful when we want to add, yeah. But when we want to get these atoms without reduction and to process them further in Python, and when we want not to add atoms to the program, then parsing is useful. But when we want to get these atoms without reduction and process them further in Python, okay. You want to make some expression, now you want to make something in Python with this. But if you want to just add atoms to the atom space, you can might as well just run meta with this. You don't need to go through the atom. Okay. Besides add atom and remove atom as well, space objects have query. Have a query method. Okay, let me take this database. Then I'm gonna make a meta file. Call this parents meta. And I put this here. Yeah. So that I don't type these strings. I guess this has its pros and cons. Yeah. Okay, so do this and then meta run this. Oops. Like this. Okay, so we added this to the database. These parents. Now we say pattern. So I'm gonna do roughly what they do here. Def pattern. Now I say py meta parse single. Then a string. Parent x bob. Yeah. Okay. So this would be a Python. Yeah, it's a Python object. This is a meta pattern. And now py meta space query for the pattern. Query is also a function that is exposed. What is that? Space objects have a query method. Yeah, this is new. I don't know. This is new. Okay, this returns nothing. That sounds wrong. Parent $x. That was I typed the wrong thing. Okay, so now I get these rules here. This is new. They never talked about something like this. Okay, it prints like these Mathematica rules. I think this is almost the same. This is some kind of mapping. Tom x Pam x. Okay. You kind of see that parent Bob. Okay, that this came out to Tom and Pam. Okay. Query. Okay, query is new. I don't know. Query was not something. This was not a concept up until now. In contrast to match in meta itself, query doesn't take the output pattern. That's true. Yeah. Okay, that was only a single input pattern. But just returns options for variable bindings. These are options for variable bindings, okay? Which can be useful for further custom processing in Python. Okay, so query was one more low level than the match that we always used in meta. Okay. It would be useful to have a possibility to define patterns directly in Python instead of parsing them from strings. Do they say now how to do that, or I guess we're building now some stuff inside Python. Okay, meta-atoms in Python. Class atom in Python has an implementation here with links to a GitHub file. Okay, this is class atom in the Hyperon atoms subpy. Atom free delete equal representation atom to string get meta type iterate result append. From this makes atom iterate self C atom. Oh, okay. It's just the bindings basically to the C library. Yes, S convenient method to construct a symbol atom. Ah, okay. Variable atom. So that you don't need to type the dollar things. This atom type in Python is used to wrap all atoms created in the backend of Meta into Python objects, so they can be manipulated in Python. An atom of any kind, meta type, can be created as an instance of this class, but classes symbol atom, variable atom, expression atom, and grounded atom, together with the helper functions, are inherited from atom for convenience. Okay, so symbol atoms. This is when I type foo in Meta. Or this was also a symbol, I think. Yeah, these things. Symbol atoms are intended for representing both procedural and declarative knowledge entities for fully introspective processing. Such symbolic representations can be used and manipulated to infer new knowledge, make decisions, and learn from experience. It's a way of handling and processing abstract and arbitrary information. The helper function, capital S, is a convenient tool to construct an instance of symbol atom Python of this class. Its only specific method is getName, since symbols are identified by their names. All instances of atom has getMetaType method, which returns the atom metatype maintained by the backend. Okay. So let's say require Python. And from Hyperon, I will also. I just require it like this. I'm fine with this. So I'm gonna type Hyperon S as symbol atom. Okay. So here I say my atom, and this returns a symbol atom called my atom. Prints like my atom. Okay. Then you can say def sym atom. Okay, then you say Python sym atom get name is a string my atom get meta type. That should be symbol. Yeah, this is symbol atom kind symbol. Okay. Further. Now I say py get bed type Python type of sym atom symbol atom. Yeah, it works like that. We make this in keyword and with this function, and then symbol atom. How do you say is instance? Is instance. That actually is a thing. Py class. So this, and then I say, can I say? I wonder if this works. Symbol atom. I wonder, does this work naive like this? No, there's an execution error. There needs to be a Python class. Okay. Okay, this is something I never did with libpythonclj. Maybe the doc string helps me. Note that the arguments are reversed. Okay, py class. How do I make a py class? I'm not entirely sure. A py create class. Okay, this is for making my own classes. So I think there's Hyperon, and now there should be a class here in this module. There should be a class called symbol atom. Yeah, okay, this probably works. Yeah. Okay, where was I? I just built a symbol atom. Yeah. Okay, now I say Hyperon atom. This is another class, and my atom is also an instance of that. Okay. So Hyperon, a capital S, that makes a symbol atom. Alright. Let us note that as my atom is a direct way to construct a symbol atom without calling the parser. As with this parse single thing, yeah, this is probably more convenient for most things. Then it allows constructing symbols with the use of arbitrary characters which can not be accepted by the parser. Ah, even that, okay. So if I want to program like this, okay, so let's say symbol atom robot face. Oh no, wait, I'm gonna use something else. X, I like X, I don't know. Okay, so this is a symbol atom with the Unicode character X. Now I can write Python atom code, I mean. Hyperon. There's also probably expression atom. An expression atom combines different kinds of atoms, including expressions. Okay, let's keep going, because I think I need to build expressions before I can evaluate usefully meta code. Yeah. This. Yeah. So this is an expression atom. Okay, then variable atom. A variable atom represents a variable, typically an expression. There are other variables are also expressions, I guess. It serves as a placeholder that can be matched with, yeah. It's what we in meta we say $x, and that is a variable, right? That's how meta works. If I say get meta type of $x, that says variable. Yeah, okay. I think this makes sense like that. Okay, so there's this Hyperon, capital V for variable. Okay, then I say X, and this is it prints as $x. So here, get name, get meta type, and that's a variable atom. Okay, say py get Python type variable atom. Okay. Variable atom also has getName method. Please note that the variable names don't include the $prefix in internal representation. It is used in the program code for the parser to distinguish variables and symbols. Internally, it doesn't have this prefix. Okay. Expression atom. An expression atom is a list of atoms of any kind, including expressions. It has the getChildren method that returns the list of childrens of an expression. Okay, so there's Hyperon, capital E for making an expression. Okay, it takes a list of atoms as input. The example below shows that queries can be constructed in Python, and the resulting expressions can be processed in Python as well. Okay, so I already have some parent relationships, I think. So let's build a query expression atom. Parent Bob. Okay, expression Hyperon symbol. Parent. Yeah, interesting. The code like that. Then a variable, say X, just X. And then another symbol. Bob. Yes. Okay, this also prints it prints nicer than it constructs, kind of. Sure, this is an expression. Now you assert something into the meta space. I already did that. Then I say meta query with some pattern. But this time that will be the expression atom that we have here. So I'm gonna quickly do this the way that they do it here. Define that into a var, and I get Tom and Pam. Something like that, right? Tom and Pam. Okay, and I can also run meta code. But that would be the annoying thing, right? Okay, so I can actually, can I run metta-mode and have that work out? I think I can, yeah. Okay, so I can open this, I can open this string edited point. Then I run meta code inside here, metta-mode, sorry, inside here. And now I get the full Lisp experience. Okay, so match self. I'm here, I'm up here. Well, yeah, now look for parent where Bob is the child, and return something like retrieved $x. Yes, we can run that in meta and get retrieve Tom, retrieve Pam. Ignore retrieved in expressions and print Tom, Pam. Okay, sure. So for the results, I can map, and this is then Python function again. Get children. Yeah, like this, for example, doesn't work. Results. They popped here. They looked at the first item. So they're here first. Okay, these are the children. So these are also retrieved and then Tom. So that is probably symbol or something. If I would look at the first here, I would get this thing. And if I look at the first there, it's this. And if I say here Python type, that is the symbol atom. Okay. So this is a list of symbol atoms, this get children function. So yeah, what they do here is they get the first, I get the second. Does this work? This works. Okay, cool. Get children does return something that has an iterable, I think, in Python. Yeah, that's cool. This would even be cooler if this would also be an iterable already. Is it? It is. It is. It is. Wait, it is. No. I meant this one. Right? Yeah. This, I get the feeling. Okay, it's not there. Okay. I need to call get children on it. So I do that with py get children. Okay. And then I have it as Clojure data. Alright. Okay, stuff like that. Alright, okay. This is now a little bit of a mix of building expressions in Python code and here mixing with some meta code as strings, and then here operating on the results a little bit, and this is all Python, of course. Okay. Grounded atom. Grounded atom. Okay. Grounded atom is a special subtype of atom that makes a connection between the abstract symbolically represented knowledge within atom space and the external environment or the behaviors, actions in the outside world. Grounded atoms often have an associated piece of program code that can be executed to produce specific output or trigger an action. Yeah, like plus or something to calculate something on the CPU or something like that, I guess. For example, this could be used to pull in data from external sources into the atom space. To run a PyTorch model, to control an LLM agent, or to perform any other action that the system needs to interact with the external world, or just to perform intensive computations. Yeah, okay. Besides the content which is a grounded atom, besides the content which a grounded atom wraps, there are 3 other aspects which can be customized. The type of grounded atom kept within the atom itself. Okay, I can make a grounded atom and give it a type, okay. The matching algorithm used by the atom, that's kind of interesting, sounds advanced. A grounded atom can be made executable and is used to apply subsymbolic operations to other atoms as arguments. Cool, okay. So you can make a grounded atom also kind of a function, and then I can implement it in terms of subsymbolic operations. What do I see here? That just looks like... Oh, that is grounded with a mapping. It's a Python map now as a grounded thing in the meta runtime, basically. Okay, let's see. Let us start with basic usage. Capital G is a convenient method to construct a grounded atom. It can accept any Python object which has copy method. In the program below, we construct an expression with a custom grounded atom and add it to the program space. Then we perform querying to retrieve this atom. Get object method, grounded atom has get object method to extract the data wrapped in the atom. Oh yeah, okay. Alright, okay, so Python object with copy. Yeah. Okay, you can do some stuff with that. A meta runtime. Now I say Hyperon. Oh, I have this bug. I have this bug. I don't know what this is, but if I revert the buffer, it's gone. This is... I'm guessing it is from command log mode, because that's the only thing that I added. But I have no idea why. This is so strange. But yeah, either way. Doesn't matter. Just ignore this. I say Hyperon, capital E. So I build some expression now. Then I say S my key. Okay. Okay, and here now are Python objects. This is now. I mean, again, just swag in Clojure. I just type a Clojure map here, and this also works. But I need to call Hyperon G to wrap it in a grounded atom now. Okay, I guess like this. So this is this expression. Then I say meta space, and then add atom. This expression, okay. Now I can query meta. I'm gonna type it out once completely. Here with some meta codes. Okay, that's gonna be match ampersand self, then my key $x, then return $x. Okay, that just looks for my key in the meta space. Say result here, and then the result of this would be this x. 1 sec, they said env0, env0 kind of. Does this work? Ah, it works. Yeah. Okay, so this is a grounded atom. Yeah, it's kind of cute. It's kind of cute. It works. Get object that returns a Python object now. Yeah. And of course I can decide to make this a Clojure object again. As JVM. Then I get a Clojure. Oh. As JVM? I'm surprised. It's prints. Not like what I would have thought. But I can put this into a Clojure map. That for example will work. Yeah. Then I get A, B. And this time with strings. Yeah. Okay. It's a tiny downside. I would need to say keyword dice keys to get back what I wanted. But yeah, okay, so this was a grounded Python atom in between. Here we made a grounded Python atom with some Python data. And then we have this now in the atom space actually. We still have this in the atom space. Bounded to the grounded Python object. Here I queried the Python object, I queried just using normal meta code. And in the result I said get object. And that's this Python object here again. As the example shows, we can add a custom grounded object to the space, query and get it in meta, and retrieve back to Python. However, wrapping Python object directly to G is typically not recommended. The Python API for meta implements a generic class, grounded object, with the field content storing a Python object for interest and the copy method. There's also the generic grounded object. That's what we just did, right? No, capital G returns Python type. This thing is a grounded atom. Achso, okay. But grounded atom is not recommended. I should make grounded object, okay? There are two inherited classes, value objects and operation object, with some additional functionality. Methods value atom and operation atom is a sugared way to construct G value object, G operation object. Okay. There's operation atom and value atom. Okay, it kind of splits out into two things. Thus, it would be preferable to use value atom. Alright. Okay, so G is not actually what you should use. You should decide whether you have a value atom or you have a function atom. Okay. So like this, I also get a grounded atom again. Okay. Although one would need to write result get object content to access the corresponding Python object. Value object has a getter value for content as well, while operation uses op for this. Alright. Okay. Yeah, okay, good to know. So now it would be kind of cute to make a function and call that function inside meta. That would be so cool now. Should be easy, right? Operation object, right? Okay, let's see. should be easy if they have implemented it. The constructor of grounded object accepts the content argument as a Python object to be wrapped into the grounded atom, and optionally the ID argument, optionally for representing the atom, and optionally for comparing atoms. Optionally, what is grounded object? I can make a grounded object that accepts the content. So what is that? That is Hyperon grounded object. Okay, that accepts content. I see. In the grounded atom, and optionally the ID argument. Optionally the ID argument optional for representing the atom, and optionally for comparing atoms. It's kind of funny is that the optional a few times. When utilizing the content for this is not desirable. So when comparing atoms is not desirable, I can put an ID. Aha, okay. The value object class adds the getter value for returning the content of the grounded atom. Yeah, okay, it's a little bit a lot of info right now. But I have this sort of in mind here. There, for grounded atoms, you have two classes, and you have also another way of building it by using this class constructor immediately. Okay, and you can pass an ID if you want to for comparing, and then you have one for objects where you say value atom, and then you get an atom out of that, a grounded atom that you can use in expressions like this. Okay, even more. Okay, arguments of the operation object constructor include name, op, and unwrap. Name serves as the ID for the grounded atom. Op, a function defining the operation, is used as the content of the grounded atom. And unwrap, a boolean, indicates whether to unwrap the grounded atom content when applying the operation. Aha. Better to unwrap the grounded atom content. When this operation is applied, you can also unwrap, but I'm not sure what unwrapping is. Okay. While there is a choice whether to use value atom and operation atom classes for custom objects or to directly wrap them in G, grounded objects constructed in the meta-code are returned as such sugared atoms. Alright, okay. I mean, this is the only difference is that this is a class with additional methods or something like that. Okay. Okay, let's type this code. Plus, okay, say pi meta parse single plus. Okay. This is an atom now, right? I get a Python type. This is a grounded atom, right? Okay, this is a grounded atom. Okay, and this implements the get object function pi get object, and that prints as plus, and if I say Python type here, I get operation object. Okay, it understood that plus is building an operation object. Okay. Then you say get object op. This is an error. Wait, why is this an error? So this is a field. An attribute, I guess, in Python. Okay, so this is, I actually already looked at this arithmetic ops something. This is like a lambda implemented in Python, prints like something. Actually, the funny thing is that I can run this with 10, 20, 30. Kind of cool. Kind of cool. Kind of cool. Yeah. This prints as a plus. Yeah. Calc. What are we doing now? Now we say meta run. Okay, and now at this point I'm gonna make a function called run. Run meta. Yeah, this is already useful. Okay. Okay, so run meta and then some meta code plus 1, 2. Okay. Yeah, it returns 3. Def calc. So I could say here. Or just first. I think this should also work. Yeah. Calc is just 3. It's this is now a Python number. I think this automatically is what is this actually? It's a Python generic py object. Okay, we still have a Python object in our hands here. Yeah, okay. Cool to know, I guess. Oh, so this just prints as 3. But this is actually a value object. This is actually still a meta value object. Alright. If I say Python type of calc get object, this is value object. Okay. Get object value. Alright, okay. I'm not remembering this, but hopefully I will remember that I can look it up at this spot here for the moment. Yeah, so value object value, that gives you back a Python object. Okay. Now run meta. My secret symbol 42. Okay, this puts this thing into the meta atom space. Add the expression to the space. Then let pattern. Now I'm gonna say hyperon e. Oops. Make an expression with a variable x 42. Okay, ask. Yeah, okay. I need a value atom here. I need a value atom 42. Yeah. Okay. 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 Okay, alright, okay. Now query the space. Okay, query the space. Gonna do what they say. Give me the space and then query with the pattern. And this returns this result set here. Yeah, X is now my secret symbol. Okay. As can be seen from the example, value atom 42 can be matched against 42 appeared in the Mecha program, although it is not recommended to use grounded atoms as keys for querying. It's not recommended to use grounded atoms as keys for querying. Okay. Apparently, there's a textual representation of grounded atoms, from which atoms themselves are built by the parser. Yeah, we said here 42. But it is possible to introduce such textual representations for custom grounded atoms. I mean, this is a rhetorical question. Is it possible to introduce something? Yeah. Okay, I'm not sure. I'm not sure when I need that, because I can build Python objects with Python code now. But yeah, okay. If you want to write meta code that the parser is passing into grounded atoms, then this next page will come into play. The answer is yes. The Python and Meta API for this is described on the next page.